demonstrating my homemade AM transmitter with which I attempted to get companies to sell it as a kit, because you can see the size difference in this one. And this is a transmitter using very cheap components. The components are like less than €2, whilst this one, yet the tuning capacitor, if you buy these alone, these cost €2, €3 if you buy just the tuning capacitor. But then you have the Farad dot bar antenna, which is not well available, and if you find it, it's expensive, and mine uses very cheap components. But companies said, first they said, sounds good, we are interested. Then they said, well, insert reason here, we are not interested anymore. Yeah. Okay, so what I'm demonstrating is I'm tuning it to the lowest frequency. The radio is set to the lowest frequency, 522 or something, and we have static. Now let's tune the transmitter. It can be tuned with the potentiometer. And now I'm tuned to the radio. Okay, where's volume? What I want to show you is how good the amplitude modulation is. Like I said, if you tune it, for example, here is the center of your frequency. This is where your transmitter is on. If I tune this one to the higher frequencies, this would be your main frequency. You have to tune your radio next to the frequency to hear it. If you tune it on your main frequency, the audio is bad, silent, distorted, and doesn't work well. This is not what you want. I wanted to have it on center frequency because this is how works. This is how amplitude modulation works and is supposed to be. Now let's test this with my circuit. I have it on the lowest frequency now, 522 something, 522, 525 kilohertz in that area. So now I'm center on frequency. And we have good AM. This is next to frequency. Next to frequency. Spot on. Okay, as you can see, it works. Now I'm tuning my radio to the highest frequency, or very high. I'm making it a different way. I tune this one up to the highest frequency. Let's see where it is. Let's use my receiver and see where it is. Let's see. Okay, AM 5 kilohertz. Let's find it. Where is it? Where is my transmitter? It's the thing is that it is in some bad. Oh, it's very high. It's here. It's over 1600. It's 1715. Let's tune it to 1605, which is about the top of the frequency in the German AM band, or somewhere in that area. Yeah. Okay, not too easy with one hand. Well, must be somewhere. Well, I can see that it's transmitting. There it is. This is the middle. I want a higher frequency. I want a fair comparison. 1300. Okay, then just go to the top like before, but then we are somewhere 1700, which is not a big deal because this radio goes to 1700. Let's see, maybe this time. Yeah, doing something like this unprepared isn't the best. But you can see we are very high now. Let's see what the radio does. So spot on. We are spot on frequency, and we do not have any parasitic frequency modulation. This one has, mine does even go further, bigger frequency range, very good sound. Let's lower the volume, it's quite loud. Here you can see FM, you can't really hear much on FM. Yeah, so okay. Another thing with my transmitter is that it uses a VCO, which means voltage controlled oscillator. Okay, let's listen to the music a bit. Let's see. Let's hear. And as you can hear, perfect audio quality from my denied transmitter. And it does use a VCO. That means you can control the frequency with a potentiometer. Not with a tuning capacitor, you can use a potentiometer. And you could desolder this one from the board, then take a long lead and take one of these potentiometers, mount it outside of your case or housing, wherever you want to put it in, and then comfortable from the outside you can control the frequency. Also, I stabilize the voltage from the oscillator. That means if the battery voltage is draining, getting lower, the frequency will remain spot on where it is. Yes, but like I said, I attempted to get companies to make my kit, like companies made this kit, and all I did receive was denial. First, they say, yes, your project sounds interesting. Second, they say, no, we are not interested in it. And this has been going on for more than a decade, and I think you can understand why I'm somewhat biased seeing others getting their kits made. Yes, so this was one of my many constructions I wanted to publish, and it got denied. If you would take an oscilloscope and connect it to the output, you can measure a clear sine wave. Because previously I've made a transmitter using a simple technique. This is like the old transmitter, but it was advanced. And it had somewhat of a triangle square wave-ish waveform. And some people who tested it complain, the waveform sucks, make a proper waveform. And so this one provides a pure sine wave all over the whole band. It does make a sine wave from 525, and it does make a sine wave on 1.715 megahertz. Here you can also see the AM. The flashing bar indicates AM. Yeah, so this is a show and tell of my transmitter, which sadly really got denied quite often. Thank you for your time. Thanks for watching. Best regards, Stefan.